in topic 6.4, we're going to be talking about the distribution of energy sources, the formation, the amounts of these various energy sources that are available on Earth. So we'll start by talking about the formation of fossil fuels. Again, fossil fuels are coal, petroleum or oil, and natural gas. And each of those types of fossil fuels was formed in different manners. So we'll start with coal. Coal is formed from large areas of plant matter, terrestrial ecosystems, in which 300 or so million years ago, there were huge forests of giant plants that died off. And when they did, they were compacted, buried under soil and water through the pressure and the heat within the earth. Though that organic material that was trapped underneath this material formed into coal. So terrestrial producers, huge swamps, huge forests, are what developed into coal. Petroleum and natural gas formed in a different way. They formed in the oceans. So 300 to 400 million years ago in the oceans, there were trillions of tiny little sea animals and plants that were buried underneath. When they died, they sank to the ocean floor where they were covered with sand and silt. And then over the last 100 million years or so, they were compacted as well. And they are the types of organisms that produce oil and natural gas as well. So coal and petroleum and natural gas have different sources. Again, coal coming from terrestrial ecosystems and petroleum, natural gas coming from marine ecosystems. And so when we're talking about these fossil fuels, we have some terms that we use when we're talking about sort of the economics and availability of these resources. So the term reserves are the deposits that have been identified from which we can extract a material from profitably at current prices. Okay? And when we take those materials out of the earth from the reserves, they become depleted over time because these are finite resources. And so that can eventually lead to what we call economic depletion, which is when there still is the resource available in the earth, but the cost to bring it out and extract it is more than what the actual deposits are worth, and therefore it's no longer usable economically. And this is sort of like totaling a car. When the cost to repair a car is greater than the value, we say the car is totaled. That's sort of the idea about economic depletion of resources. And finally, depletion time is a term that we use to tell how long it will take before a given resource is depleted, given current rates of usage. And so when we look at these graphs here, what we see is sort of a pattern that typically applies, where this red line represents when a material from the earth is abundant. Okay, it typically is exploited very, very quickly, and we extract much of the material. As the amount starts to decline, what happens is we become more aware, and we start to then, consider our use of these resources, start to recycle more. We start to improve technology. Prices increase for this resource. And then finally, once we get to C, this is when the material is being utilized at a rate where it's being depleted. And so prices rise. We continue looking for more sources of this material. We're more focused on preserving it by reducing and recycling and reusing that material. This is the typical pattern that we find in terms of resource use. We also know that fossil fuels are really important in various areas for production of energy and many other uses. And so this is a graph that was predicted by a Shell oil company geophysicist named Hubbert, and he was looking at trying to predict when the production of oil would reach its peak and how the exploitation of oil would change as we reach that time. And so we tried to predict using this curve. It's called the Hubbert curve now. When there would be a peak in oil extraction in the United States. And so what Hubbard found was he predicted it was around 1970 was the upper bound when he thought we would reach peak oil production in the United States. And we can see the green, so the red is his model predictions. Green is the actual amount of oil production in the United States. So we could see, obviously, his model, this is in 1956, is when he was making these predictions. So the model followed that pattern pretty closely. Okay? But the peak oil production did go higher than his prediction, but it did peak around 1970 and started to decrease after that. But then what we see is it didn't continue following his curve, but there's actually been an increase in oil extraction that happened in the middle of the 2000s. And again, things that can change this prediction were things like new technology, new exploration, and different demands for those materials as well. So when we think about these natural resources, let's start with oil. We're going to look at a bunch of maps that show sort of where are these oil reserves or other reserves. And so we can see the colors represent the proven, that means the discovered oil reserves in these different places. There can be new discoveries of oil. Oil companies are always looking for more sources to exploit. And so we can see for crude oil, we have the Middle East, Saudi Arabia, for example. We have high amounts of crude oil reserves there. Canada has a fair amount of crude oil as well as Venezuela, and also some in Russia as well. So we can see this map shows us sort of that distribution. If we look in the U.S., if we're going to focus on the United States, again, most of the crude oil that's present, there's a bunch in Texas, some in California and Alaska. There's some offshore in the Gulf of Mexico as well. And then up in sort of the upper Midwest, Great Plains area that we see up here. So that's where you find crude oil in the United States. If we think about natural gas, there are large amounts in northern Asia and Russia. Okay, there is a significant amount, again, in the Middle East. The U.S. has a large amount of natural gas as well. And also, you can see it distributed throughout other areas, China as well. If we think about the U.S., the gas production is spread in various areas. So again, we often find natural gas in association with crude oil. So again, we see a lot in the Gulf of Mexico, a lot in Texas, in California, North Dakota. So we see a sort of a similar pattern, but then we also see this gas that's present here along the Appalachian Mountains, and again, into Pennsylvania, and this is where we'll get into hydrofracking. Okay. If we think about coal, the U.S. has a fair amount of coal as well. Russia, China, India, Australia also are areas with large coal reserves. In the U.S., we see again the Appalachian coal reserves here. Okay, we can see other areas as well where you have smaller amounts of coal, and this also shows sort of the different qualities of coal. Remember, anthracite is the highest quality, highest energy density coal, and lignite is the lowest. So we see different parts of the U.S. and where coal can be found. And often what we see are an association between petroleum, crude oil, and natural gas. They're often found in areas that are found together in given areas. And what happens is that when we find oil, it often comes from, it's trapped in rocks. And we can see in this model here, we have the shale. Shale often contains fossil fuels in it. This is where the oil and the natural gas came from. This is the source rock. And that petroleum and that oil, that crude oil, it migrates in time because of density to the highest point in a formation that's porous. So what we can see here is this sandstone that's sandwiched between these layers of shale. It's permeable to this crude oil and natural gas. So the shale, that's the source of the oil, it moves through the sandstone, but then it gets to this impermeable layer. So here we have a cap. This is impermeable that holds the oil and natural gas sort of and contains it. So these are areas, this oil deposit, and it has natural gas on top of it, is an area that can be accessed by companies exploring and then extracting through an oil well or some other means, extracting the crude oil that's in this deposit and extracting the natural gas. Okay, but the thing to keep in mind is that the source is this bottom layer. And then we have the permeable layer and then the impermeable layer on the cap rock. That's how these deposits are often found.